Before we get started with today's show, I'd like to thank Dr. Mart Ottenheim for providing me with some of the wonderful material and insight that went into this episode. Jean-Baptiste Lamarck casts a long shadow over the theory of evolution. Lamarck was a brilliant man, and he did a lot to push evolutionary theory forward. I've done episodes on Lamarck in the past, and it's worth revisiting why he casts the shadow he does. His shadow is composed of a misconception, though, and today we'll explore that misconception by showing how Lamarck would have explained the description of a little fish discovered in a cave in 2015. Yes, a cave. And no, this wasn't the fossil of a little fish. It's a living, breathing example of a troglobite.
There is grandeur in this view of life.
Welcome to Evolution Talk with Rick Coast, an introduction to the oldest story ever told.
To start, let's define what a troglobite is. It's a species that lives in underground environments, especially caves. Not by choice, really. They're there because, that's their habitat. In 2015, a spelunker named Kreiselmaier set his sights on exploring the Danube-Aach cave system in South Germany, and I'm sure I pronounced that cave system wrong. Anyway, Kreiselmaier wasn't only someone who liked to explore caves on foot, he was also a diver. Water-filled caves presented a thrill. The cave system was a challenge. It had very cold temperatures, stronger than normal currents, and extremely low visibility because, it's a cave. Things were normal as Kreiselmaier made his way through the cave system and its labyrinth of tunnels. Other than the submerged tunnels and cave walls, there really isn't much to see. It's more about the adventure. And being the adventurous sort, Kreiselmaier forged ahead. Then he saw something. It was something pale in the water. He caught a quick glimpse of it at first before moving closer, shining his light in its direction. He saw it again. It was a fish, a small, pale fish. Kreiselmaier knew he was looking at something unique, so he took a picture of it. The picture depicted a fish with an elongated body, about 8.5 centimeters long, large nostrils, and minuscule eyes that didn't look like any eyes he'd ever seen. They seemed to curve inwards. Kreiselmaier sent the picture to the University of Constance, where Dr. Jasminka Behrman-Godel had a chance to see it. Dr. Behrman-Godel's area of study is the environmental factors that change the genetic structures of freshwater fish. She knew the images supplied by Kreiselmaier were unique. Now, that cave isn't a habitable place, not only for divers, but for any animal. It never gets above 10 degrees Celsius or 50 degrees Fahrenheit. Plus, there's the problem of food. You won't find nutrient-rich algae on the rocks due to the lack of light. What you will find, though, is bacteria. And this is what the fish fed upon in the cold darkness of the cave. Kreiselmaier brought back some live specimens for Dr. Behrman-Godel, and it was confirmed. It was the first species of cave fish ever found in Europe. DNA analysis revealed it was related to the loaches. It's a family of freshwater fish one could find in the nearby Danube River. So how did they get there? Well, it's impossible to say. But up until 16,000 years ago, that area of Europe was in cold storage. Somehow, after the end of the Ice Age, the ancestors of the cave loach found themselves trapped in the cave's waters. As they evolved to survive in their new, inhospitable habitat, they lost the dark pigment that is common to loaches. Their small nostrils grew larger, and their eyes shrank to half the size of their surface cousins and became virtually non-functional. And now, this is where Jean-Baptiste Lamarck comes in. What would Lamarck have said if the cave loach had been presented to him early in the 1800s? Well, he would have held it up as being a perfect example of his theory of adaptation. According to Lamarck, it all has to do with how an animal uses or doesn't use certain organs. This can be influenced by its environment, and in this case, a cold, dark environment where food is hard to find. Through the magic of a two-way radio using tachyon signals, I can call Mr. Lamarck.
Hello?
Hi, Jean-Baptiste. I'm Rick Coast from the podcast Evolution Talk, and I was hoping I could ask you a couple questions.
Podcast?
Never mind. It doesn't matter. But why do you have a British accent? I thought you were French.
Don't worry about it.
Okay, well, I'm calling about cavefish. Why, Jean-Baptiste, would a fish living in a cave lose its pigment?
First, let us consider the temperature. The cold temperature reduces the overall metabolic rate of the fish. They would have less energy to allocate to non-essential functions, such as the production of pigmentation.
Really?
Yes. The use and disuse of organs principle suggests that organs or traits that are not used will gradually diminish in size and functionality. Since cave fish are living in complete darkness, their ability to perceive and produce color becomes less important. The organs responsible for pigmentation will begin to degenerate. This disuse of pigmentation will eventually lead to the loss of coloration altogether.
So with the fish, because a feature isn't used, it becomes weaker?
Naturally.
Is that why it might lose its eyesight?
Does it need eyes in the dark?
No.
Then that is why.
Well, what about its nostrils?
What about them?
They're small.
How does it find its food if it can't see it in the dark?
I guess by smell?
See? If you don't use your eyes, you lose them. If you can't see your food, you must hunt for them with your nose. Your nose becomes stronger over time. That is how an animal adapts.
You have to hand it to Lamarck. He makes a strong case for adaptation. But we know that's not how it works. Let me explain. First, the cave fish found in the cave isn't the only cave fish in the world. It was the first, though, to be found in Europe, but there's also cave fish found in Alabama and there's also in Mexico, to name just a couple. The Alabama cavefish has also lost its eyesight and lacks pigmentation, and it has a flattened head, no pelvic fins, and has a type of sensory nerves on its head and sides. The ones in Mexico, which are a type of tetra, is also blind or are also blind and practically translucent. Now, to add to that, there's a species of cavefish in Thailand that sticks to the walls of the cave using fins that really look like wings. Kind of creepy. But it's understandable. These cavefish didn't lose their eyesight or pigmentation because they stopped needing them. They lost it because of evolution by natural selection. So let's start with those eyes. If a fish in an above-ground river is born with, say, a genetic mutation that reduces its ability to see, what'll happen? Well, it probably won't last long. It'll either fall prey to another fish, or it will starve to death because it can't see its food. The mutation will be quickly wiped out of the gene pool. But not so with the fish in the cave. I mean, yes, they could be wiped out too. They would need to adapt quickly, though. But a mutation that reduced their eyesight wouldn't be so bad. They can't see in the dark anyway. A reduction in eyesight actually has a side benefit too, less energy. The brain and optical system allocated to vision does require a lot of energy. Lose it or diminish it, and you get some of that energy back. The mutations that disabled the genes involved in eyesight ultimately had a sort of benefit. And the same thing goes for the widening of the nostrils. A mutation that widens the nostrils above ground may not be a benefit or a disadvantage, and it might stick around. But for the cavefish who can't see their food, it's definitely a benefit when it comes to locating that food through the sense of smell. Now, I'd call Lamarck back to break the news to him that, well, he was close. Adaptations have nothing to do with use and disuse. It's genetics and mutations. Something an organism has no control over. Sorry, Lamarck. I hope you enjoyed today's episode of Evolution Talk. I'm Rick Coast, and if you find value in this show, please consider supporting it at evolutiontalk.com. I'd love to keep the show alive and without ads, and I can only do so with your assistance. So help spread the word. Share the show with your friends. And at evolutiontalk.com, you'll also find information, recommended books, and also ways to contact me. I'd love to hear from you. I hope your week is going well, and until next time, please take care of yourself.
Evolution Talk is a Rick Coast production.